Hi all. So my 130s, so far I've covered in videos that you can find on YouTube on my channel. I've covered numbers 1 through 10 of the chapter 6 assignment. I've also covered numbers 11 through 20. To speed things up a little bit so we get through chapter 6 hopefully this week, I'm going to go ahead and cover the odd problems today. So I'm going to move 21 through however much I can get through. And I'll continue this tomorrow in the Zoom with the other 130 group. Let me go ahead and clear this out, and I'm going to start with number 21. Change colors here. So we're trying to simplify the square root of 180. So the first thing that we're going to do, we briefly talked about this last time before we ended, but this is not a perfect square. Okay, 180 is not a perfect square. So what you're going to need to do, take 180 and prime factor it. So we have 18 times 10, 6 times 3, 2 times 3, prime, 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 and 2 and 5. And actually, the more I do this, I feel like I've done this one on a video before, but it's okay. I'm just going to start from here anyway. So what we find is that 180 is equal to 2 times 2 times 3 times 3 times 5. Okay. And writing that in exponent form, that's 2 squared times 3 squared times 5. So what we're going to do, we're going to take what 180 is equivalent to from its prime factors and put that underneath the radicand here. Sorry, underneath the radical sign in the radicand. So let me be very specific. Radical sign is here. Radicand is where this pink stuff is.
Okay.
All right, so we have square root of whatever 180 is prime factored. That's 2 squared times 3 squared times 5. Remember, every time you have a pair of a factor, you're just going to take out one of those prime factors by itself. So the square root of 2 squared would be 2. And the square root of 3 squared would be 3. What do you do with those two factors? You multiply them outside of the radical sign. Since 5 doesn't have a pair, you just slap that guy underneath the radical sign and leave it there. So we're left with 6 root 5 for question 21. All right, let me pause. All right, you guys, so now we're on number 23. We have the cube root of this value 250. Again, if you try, and I'll go ahead and do it right here, the cube root of 250 is 6.299, blah, 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 some change. That's not what you want. What you want to do is make sure that you don't leave any cube roots, any perfect cubes as factors of 250. So let me repeat that just to make sure it's clear. We don't want any perfect cube factors from 250. So let's prime factor 250 off to the side. That's 25 times 10. It's 5 times 5. You have your primes. And you have 2 times 5, again, prime. So 250 is equal to 5 cubed times 2. So again, we're going to make our radical here. And then we are going to put 5 cubed times 2 in the radicand. The cube root will undo the cube and you will get a 5 out from there. The 2 doesn't have 2 more 2's attached to it. So you're going to leave your cube root 2 right next door. Okay. Let me save that. And then we pause. All right, so far so good. One thing I do want to mention, you must write the cube part, the 3 for the index here. If you don't have a cube root there, like say you write 5 square root 2, that is not the same as 5 cube root 2. And we'll talk about that a little bit more later. All right, go ahead and take a picture if you need it. I'm going to clear this out, and we're going to move to number 25 next. And then I think after number 25, I'm actually going to take a little bit of a break so that we can look at an exercise using number 24, because this is a perfect problem for the activity I wanted to give you guys this week. Go ahead and clear that out. So number 25, you see that we're adding radicals this time, right? So for this, definitely look at it on ALEKS. Don't get creative. Like you can't add the root 5 and root 45, root 20. Can't do anything like that. Instead, what you need to do is simplify the radicals first. And then you're going to treat like radicals like terms. So a quick example. If I have root 2 plus root 2, okay, that's like saying, oh, well, what if I had x plus x? That would give me 2 of the x's, right? So I have 2 of the root 2's. Okay, but if I have, let's see, second quick example. If I have root 3 plus root 2, these are not like radicals. This would be like adding an x and a y. Okay. Go ahead and take a picture of that if you need to. So I'm going to clear the bottom part out. So here we have 2 root 5 plus 3 root 45 minus root 20. So what we're going to do is first break down 5, 45, and 20 into its prime factors. So five is already prime. So 5 is just going to equal 5. For 45, you're gonna have 9 times 5, which is 3 times 3 times 5. So 45 is 3 squared times 5. And then 20 is 4 times 5. And 4 is 2 times 2. So 20 is 2 times 2 times 5. That's 2 squared times 5. Okay. So what we have here, we have 2 square root 5 already primed, so I'll just leave it black again, plus 3 square root, we have 3 squared times 5, and then minus root 20 is 2 squared times 5. So keep the 2 root 5. You have 3 here. A 3 will come out from here and be multiplied to the 3 in front. And then the 5 doesn't have a pair, so keep root 5. And we have minus. Your 2 here has a pair, so 2 is going to come out. And then you're left with square root 5. So where the like terms come in, the like radicals, that comes from the radical 5s. You do one more step here. We have 2 radical 5 plus 9 radical 5 minus 2 radical 5. So 2 radical 5 will cancel with 2 radical 5, and you are left with 9 root 5. To be more specific, this 2 root 5 cancels because the second 2 root 5 is negative. Okay, let me save that and make one more point again. I'll put it in red again. For this particular problem, your correct answer should be 9 square root 5. If you were to put 9 cube root 5, this would be wrong. You would need the square root for this particular problem. All right, so let me pause. All right, so we are on number 27 now. We have a negative cube root 32x to the 14th minus, and let me make that a different color. Make it blue. 32x to the 14th minus 2, we're gonna have a cube root, 108 x to the 14th. So now it gets a little bit more confusing because we're also putting some variables in there that are not perfect cubes, and we have numbers that are not perfect cubes. So we're actually going to start off very similarly. Let's prime factor. Just the 32. That's 8 times 4, which is 2 times 4 for 8. And then both 4s break down into 2 and 2. So 32 is 2 to the 5th. We're also going to prime factor the 108. That's going to be 54 and 2. 54 breaks down into 27 and 2. 27 breaks down into 9 and 3. And then 9 breaks down into 3 and 3. So primes, circle them. It's kind of helpful so you can see them visually. So 108 is 2 squared times 3 to the third. I'm going to move this guy up here. And I'm going to move, no, didn't do it right. This guy, come on, up here. Take a picture if you need. I'm going to erase this on the bottom. So remember, just change the things that you're actually replacing. Everything else stays the same. So we have not changed the negative in the front or the cube root. And again, emphasis, you do need to write this. It's important, that cube. Cube over the root, cube root. So 32 is 2 to the 5th. And then you have x to the 14th. For your second radical, you have a subtraction of 2. That's a coefficient out in front. And then you have your cube root. 108 we found was 2 squared times 3 cubed. And then we have x to the 14th attached. Now, honestly, if this next part confuses you, what I would suggest, even though it's kind of a pain in the butt to start, actually write out all of these values. Like, so just a quick thing. If I have 2 to the 5th, that's 2 times 2 times 2 times 2 times 2. And then x to the 14th, 14 of them, right? If you need to do that. So it's helpful. But you see this index out here. That tells you want to find perfect cubes underneath the radical sign. So we're going to keep our negative cube root. Definitely practice with chapter 4 again, your exponential rules. 2 to the 5th is going to be 2 to the 3rd times 2 squared. And then for this part, it's a little bit abstract, but think. If I had 14 and I divide it by 3, how many times would I get that to come out evenly? Let's do a long division for this part, just so you can see kind of what I'm doing here. I know 3 goes into 14 4 times. 4 times 3 is 12. Gives me a remainder 2. Okay. So what I found from that is that I can put x to the 12th and x squared next door. Let's color code this a little bit more. See this part here? That's right here. And then the remainder, let me use a different color. The remainder is right here. Now, before I go into the other radical in terms of simplification, I want you guys to understand why I did this, so I'm going to simplify this radical first. I have a negative cube root 2 to the third is 2 squared. And actually I can skip that step. Hold up. Let me redo something. Negative, I'm going to put my cube root here. Notice I've left a little space in front. That's for any perfect cubes I find underneath the radical sign. And then all of this space under the radical sign here is for leftovers. So you see we have 2 to the third. A 2 is going to come out. And then we have x to the 12th. Well, how many groups of 3 x's is that? It's 4 groups. So this, let's see, need a different color. Running out of colors here. Okay. So then I figure out what's left over. I still have a 2 squared. And I still have an x squared from here and here. Let me save a picture. Go ahead and take a picture of it if you'll need it. I'm going to clear out this part. Okay, so let me continue and then I'll ask you guys if you have questions at the end. So subtraction of 2. We're going to have our cube root, but again, I'm going to break down the x to the 14th. So I still have my 2 squared. I have my 3 cubed. And then I have x to the 12th, x squared. So I'm going to keep this piece here, the minus 2. I'm going to leave myself some space in front of the cube root and some space under the cube root. I see that I have an x cubed here. Sorry, a 3 cubed here. So 1 3 will come out. And then x to the 12th. That's 4 groups of 3 x's. What's left over? 2 squared x squared. So then over here, for our first radical, that's negative 2 x to the 4th cube root 4x squared. Second radical, negative 6 from multiplying the front, x to the 4th cube root 4x squared. Note when we do that, we have like radicals. Okay. So what we're going to be doing is adding the negative 2x to the fourth, and the negative 6x to the fourth. That's going to give me negative 8 of these x to the fourths multiplied by our like radical cube root 4x squared. Let's go ahead and take a picture of that. I'm going to pause because I'm sure there'll be some questions after this one.